So, diri naatay irreversible unimolecular type first order reactions. So, consider daw na ang reaction na A forming to product. So, unimolecular because A lang. This is A going, mahimo siyang into a product. Unimolecular kay isa lang ka type sa reactant ang naa. And then irreversible because uh, all of the reactants would become products, and walay products mabalik into a reactant. First order um, first order overall. So for this, since first order, and then we need we can write the rate of reaction of A as negative RA. Yeah. We have DCA negative because disappearance. TT, okay, since magamit pa siya, the reaction. K CA. So, ano. So, evaluating these two terms, we have negative DCA over DT is equals to KCA. So, using separation of variables, so we get negative DCA over CA is equals to KTT. So, pwede na i-transpose na nato diri sa pikas, the negative 1, or but in our case, we'll transpose it to this side. So, we have DCA over CA is equals to negative KTT. So, after that, integrating, we have DCA over CA is equals to negative KTT. So integrating the two, so we have this one is ln. No, we forgot to put the limits. Limit CAO in the start of the reaction to any time. CA 0 to T for this side. So ln of CAO CA is equals to negative K T limits from 0 to T. So we have evaluating the limits, ln of CA minus ln of CAO is equals to negative K T minus 0. So ln of CA divided by CAO, property of logarithmic, is equals to negative K T. And then since we need to find, it's either we need to find the equation for CA or time. So in our case, we need to find the equation for CA. So applying um, um, the property of ln, so we have CA over CAO is equals to E negative K exponent negative KT. And then transposing the CAO or multiplying CAO to both sides of the equation. So we get equation CA is equals to CAO E raised to negative K. So CAO E raised to negative K. So this is now the equation you'll be using for a unimolecular irreversible first order reaction given this type of chemical reaction. But in uh, terms of conversion, so if you remember, so next is here is we have in terms of conversion. So as we all know, conversion formula for conversion, the relationship of conversion XA to concentration is Ca, or any concentration, CaCaO 1 minus Xa. So we could either put this, substitute it here, then solve for Xa, because usually this ask is Xa. In some problems, it's the conversion of a certain reactant. So we need to find the um, we need to find the equation use for XA and in terms of CaO, because usually CaO is given. We could use that, or we could integrate also. So by integration, we have Ca is equals to CaO minus CaOXA with differentiate both sides. We have dCA is equals to CaO is a constant, so this will become 0. This one is negative CaO dXA. So remember the rate reaction of Ca. We have dCA over dt is equals to kdt. No, kCa rather. Ca. So we have to replace this term with this one, but since we have a negative here and a negative here, we could transpose it in this side, becoming negative dCA, so we just have to replace it with this one. We have CaO dXA over dt is equals to K and then Ca is in terms of CaO and Xa, so we have CaO 1 minus Xa. So we have CaO on both sides, so we can cancel this 2 out. So we have dXA so we have dXA divide dXA over dt is equals to K 1 minus Xa, right? Then by separation of variables again, so we have dXA over 1 minus Xa is equals to K dt. Then integrating with limits from 0 to t. Here is 0 since we start the reaction with 0 conversion, and then Xa conversion at a certain time. So we have negative ln of 1 minus Xa with limits 0 to Xa is equals to k t 0 limits 0 to t. So as estas, so we have that negative ln of 1 minus xa limits 0 to xa is equals to k t 0 to t. Inputting the limits, we have negative ln of 1 minus xa. Xa lang papalitan natin. So xa will be replacing xa with xa again. So minus xa minus because in evaluating limits, ln of 1 minus 0 is equals to k times t minus 0. So we have negative ln of 1 minus xa and only plus ln of 1 is equals to k t. ln of 1 is what? What is ln of 1? ln of 1 is 0. So this is 0. So we are left with negative ln of 1 minus xa. 1 minus xa is equals to k t. So ln of, is this happening? So ln of 1 minus xa is equals to negative kt. Applying the property of ln 1 minus xa is equals to e raised to negative kt. Transposing variables, so xa is equals to 1 minus e negative kt. So this one is another formula that you can use if you are just given conversion instead of concentration. But if you're given concentration, you can use this formula also. Okay, so that is it for irreversible unimolecular type first order reactions if your reaction is just a forming into products. Thank you.